Number system. We are going to study this chapter. This chapter is very basic and easy to understand. Based on this chapter, many concepts of subsequent chapters are related. In calculus, in 11th and 12th also, you need to understand these numbers, this system. So in number system, we study numbers. So what are the numbers? Standard definition says that it's a mathematical object. Mathematical object used to count, measure and label. We can also use the numbers to do a comparison. So it's an object. In mathematics, we use counting, measuring and labeling, and comparison also. So 3 boxes. We'll count 1, 2, 3. So while counting we use the numbers. Now measure. Eiffel Tower. Eiffel Tower is 330 meter tall. So we measured. While measuring we use a number 330. Now labeling. House number 512, 512 A. So we have used the number to label the house. Now comparison. So 2 trees are there. A is 10 meter tall, B is 5 meter tall. Which one is taller? By looking at the number we can say that A is taller than B. So we have used the number to make a comparison. Number universe. So like our universe is also of oval shape. This I represented it like oval shape. So it's a set. Number is a universal set. Other sets like irrational, rational, integer, whole, natural, all are subset. So it's a Venn diagram representation of number system. So in Venn diagram, a universal set is there, then further subsets are present. So number is the universal set. Now rational numbers and irrational number are 2 subsets. So number is the universal set, others are subset. And further downward classification. We will revisit this classification later on also. This is just for introduction. So rational and irrational. Now in rational number you have integers and fraction also. In integer you have whole numbers and negative integers also, 0 also. So we'll go to natural numbers first. What are natural numbers? Natural numbers are counting numbers. 1, 2, 3, counting. We never count -1, -2, -3. So the smallest natural number is 1. It is denoted by capital N. And from here we start. 1. This is the starting counting number. Example 1, 2, 3, 100, 600, 786. Now whole numbers. Natural numbers together with 0. So 0, 1, 2, 3 all are whole numbers denoted by W. Still we are not taking account of negative numbers. So smallest natural number is 0. It's 0. So 0, 1, 2, 3, 4. Every natural number is a whole number, right? But not every whole number is a natural number, because 0 is not a natural number. Integers. Natural numbers along with 0 and negatives of natural numbers collectively called as integers. -5, -3, 0, 1, 2, 3, 600, 700, like that. So natural number plus 0, that is whole number, and negative of all this. So integers are denoted by Z. These are the examples. 0 is neither negative nor positive. There are infinitely many integers. Yes. Every natural number is an integer. True. But every integer is not a natural number. Like -5 is an integer but not a natural number. Reverse is not true. Every whole number is an integer. Reverse is not true. Now number line, very important concept, very important concept. Right is increasing, left is decreasing, and all integers are represented on that. Distance between two consecutive integers is always fixed. These are the rules while drawing natural number. 0 is at the central part. Left is negative, right is positive. As you go rightward, value keeps on increasing. As you go rightward, value keeps on, as you go leftward, value keeps on decreasing. Right, increasing. The middle point of number is line is 0. The number line extends infinitely to left and right side of the 0. As you go rightwards, we get bigger numbers. So any number coming right after a number is bigger than the previous number. Right, bigger. Left, smaller. Left is smaller. As you go leftward, number will decrease. Very simple concept. Always visualize. Visualize. Rightward bigger, leftward smaller. Visualize this. It will help you lifelong if you are interested in studies and job. Meaningful job. This concept, rightward is bigger, leftward smaller. Any real number and integers also can be represented on the number line. Any real number can be represented on this number line. Doesn't matter how big or small is. Now again we are coming to the number universe. Rational numbers, integer, whole number, natural number. Irrational numbers are there. All these numbers can be represented on a number line. All these. So any number can be represented on a number line. Doesn't matter how big or small that number is. Now question, can we represent all real numbers on the number line? Answer, yes. Can we represent 0 on number line? Yes. Can we represent all whole number on number line? Yes. Can we represent all natural numbers on number line? Yes. Can we represent all the integers? Yes. Like 1, 2, 3, -3, -6, everything can be represented on number line. Can we represent all the irrational numbers on number line? Irrational numbers? Yes. P, irrationals. We will learn about irrational numbers. Can two places on number lines be represented by the same number? Two places on number lines be represented by the same number. Suppose same number A and B are there. So A is equal to B because these are same, but two places are there. So first case B is rightward, but we know that rightward number is greater. Hence this can't happen because A and B are equal. So rightward is, now put B on leftward or a number C on leftward. It can't happen because leftward number is smaller. So two numbers can't be represented single number can't occupy two different places on number line. Can two different number occupy the same place? Never. If these two numbers are on same places, so these are not right or left to each other, hence equal. But we are saying that these two are different numbers, so it can't happen. So left and right, left means small, right means big. So two places on number lines means two numbers. Same place on number line means same number. So place is signature of a number, reserved for a number. Right? We'll learn more about number lines later on, and this chapter is very important. Okay, I have started from the very basic thing, and we'll take this up to a very big level. Now, how many numbers can be found in between any two numbers on the number line? Two numbers on the number line, and we know that between 2 points, two numbers mean 2 points on the number, infinite point can be made. So infinite numbers can be there. So there are infinite numbers between any two numbers on the number line. Any two numbers contains infinite number in between them. So this is like very important concept. Thank you. We'll come with bigger concepts, higher concepts.